So our next topic in Module 1 is finally into significant figures. So it takes a little bit to get used to thinking about math with significant figures involved. Up until chemistry, whenever you've added something, subtracted something, multiplied something, divided something, whatever the answer comes up to, if you've done it longhand or on the calculator, whatever that answer is, that's the answer you write down. But in chemistry, we always have to consider the precision of our measurements, and they define the number of precision that we report in our numbers. So let me give you an example of what that looks like. So significant figures are numbers that we get anytime you measure something. That's what I mean by obtain from quantitative measurements. And there's always uncertainty. Anything that you measure, there are always limits to how accurately we can do that. So the number of significant figures is the number of digits known with certainty plus one uncertain digit. I know we're saying a lot right there, but let me give you an example of what that means. So if I have a mass of 2.365 grams. What that means is that if I report that number, then I am absolutely sure that this mass is 2.36 grams, but I'm not really positive about whether it is, 0.1, 2.631, 2.632, 2.633, or whatever. And so I'm going to have to use my eye to give my best guess about that last digit right there. And so just to illustrate that, imagine that you're looking at a ruler here. We know that this measurement is in centimeters here. And if I want to say something about the length of that line right there, well, I'm positive that it's at least 20 centimeters long, right? And I know that it's less than 30, so it's someplace in between there. And so I can estimate, at least I could estimate it to say that it is either closer to 20 or closer to 30, but in this case, I might say that that's 22 or 23 centimeters long, but you can see I'm really guessing about that. I'm just eyeballing it. Now, if I have a more precise ruler, like this next one down here, I'm going to actually count that out. So I have 20, and then I have 21 and 22, and to my eye, it looks like it's actually longer than 22, so I'm going to say that that is 22.5 centimeters. So I'm always reading it to the mark that I'm sure, and I'm guessing just on the other side of that. I'm reading this to the mark that I'm sure of, and I'm giving it my best guess on the other side of that. Every time we measure something in a pipette or with a graduated cylinder, we're always going to do that. We're going to report a number to the what we know is certain and plus one uncertain digit. Okay, and that's as accurate as we can possibly be when we are determining volumes in graduated cylinders and also in pipettes. Old-time scales used to have to do that. Our scales are digital, and so they account for that, and they will tell you on the scale how accurate or how precise they are. So that's a start. We'll do some practice on significant figures in just a second.